Okay, this is a help video on 5.5 trigonometric equations, and I want to do two things. I'm going to start with solving trigonometric equations in quadratic form. I'll probably do that second, not first, and then solve trigonometric equations give the general form for all the solutions. So let's start with a particular problem or an example. We want to solve sine of x equals square root of 3 over 2, and we want to find all solutions, and probably that's the part that students are having trouble with, finding all the solutions. So let's think about it as what it's really asking you is, when, for what angles, is the sine going to equal square root of 3 over 2? Well, there's a couple of ways to think about this. Informally, you can think about it as you're trying to solve for x, meaning that you're taking the sine inverse of both sides to get rid of the sine function. And like I said, this would be informally because there are rules about when sine inverse is used, but it gives you a great way to think about the problem. Of course, whatever you do to one side, you have to do to the other. Sine inverse cancels sine, of course, with the restricted domain. So you're left with x equals the sine inverse of square root of 3 over 2. And you can plug that into your calculator if you don't particularly remember when the sine will equal square root of 3 over 2. And you will find that it's, if you're working in degrees, 60 degrees, or pi over 3 if you're in radians. But let's think about this conceptually for a minute before we formally write out the answer. We want all solutions. So what this is telling you is, because it has a restricted domain, it's telling you one solution. It's telling you the solution that is in quadrant 1, because it's positive. And it's saying, I'm going to use radians because in fact we're going to end up being in radians. It's telling you the solution for this particular angle. So that's one solution. But sine is also positive in quadrant 2. So there is another solution, and that solution has a reference angle of pi over 3, but the actual angle itself is 2 pi over 3. Okay? Now, so we have to consider both of these, and not only do we have to consider both of these, we have to consider every rotation of these. So, let's look at how we're going to write our answers. Our answer should be pi over 3 plus 2 times n pi, because 2 pi is one rotation, and n is going to be however many rotations we wish to do, where n is an integer. So n could be 1, n could be -1, n could be positive 6. That covers one of the scenarios, and it covers every rotation of that scenario, or the answer. And when I mean or, I mean the mathematical understanding of or. It's not either or like you would think in English. It is, or means either or both. So all of this has to be included. 2 pi over 3 plus 2 times n pi. And that will include every rotation of this example. Okay? So this is going to be, I'm going to make these videos a little bit shorter so they're easier to upload with my limited access. So I'm going to end this now, and then I'll be back to show you another example. Alrighty then.